All right. Hello, everybody. Welcome. Thanks for joining. Let's talk about cloud optimization and how we can take your on-prem and off-prem infrastructure using OCI and create a pathway for optimization to prepare for either saving saving resources and saving money, but also preparing the environment to lift and shift to the cloud. All right. So the first thing we do when we run this report is, and by the way, this is free. This is available if you just reach out to me, mmoon@netapp.com, or reach out to Jill, and we'll be able to provide this to you for free. And you can use it and provide feedback and just give us suggestions, things you want to make better, want to change. The great thing about this report is it's very flexible. Okay, we can make any type of changes you require. And I'll get into it in more detail as we go through each tab, and I'll talk about exactly what it takes to really build in more accuracy around cloud optimization. Okay, so first thing we do is we look at this very first screen here, and regardless of the hyperscaler you're interested in, we can support AWS and Azure for both on-prem and off-prem. We can support GovCloud and GCP for just on-prem. Okay, and what we do is we take a look at the environment from a high level. All right, so we look at the current state of the VMware infrastructure or Hyper-V infrastructure. Looking at the top left bar chart, we look at the current virtual machine sizes and how we're distributed. Okay, so if you notice, we start off with one CPU. We have 127 VMs in this environment, this lab environment I'm using. 193 two CPUs. We have 724s, 627 8s, 148 16s, and 44 40s, or over 40 or more, up to 64. And this allows us to see how we're distributed and where we stand. Now, what I do next is, moving from left to right, is look at the utilization of those instances and where they fall into buckets of 10% CPU, 20%, all the way up to 90%. You can see the vast majority of instances in the virtual on-prem infrastructure is less than 10% utilized. Okay, and once we get that count, we can identify candidates for lift and shift. Right, and then we can go right to each one of these buckets to see, where are we underperforming, but also on the inverse, where are we overperforming? Okay, where are we overutilized? And we can capture those as well. We do this for memory. If you go over to the very far right top, we do this for memory as well. And you can see there's 939 instances that are 10% or less utilized. And that can be problematic, especially when you have a lot of resources in your environment that you need to distribute fairly and ensure optimization from a bunch of different perspectives. So it's important to understand where you stand and where you need to go. Now, down here on the lower right, this is my favorite part of this screen, is the bubble chart that shows every instance and where it would fall based on those parameters that I just showed you at the top. Okay, so here we have most of the instances are pegged to 0 to 0, 20 to 10 from a CPU and memory perspective. And we take and draw axes to show thresholds where we believe instances are properly utilized, underutilized, and overutilized, okay, from both the CPU and memory perspective. You can see these outliers here. That is what I call the inverse, where you have instances that are overutilized, right, that need to be upscaled, versus down here where it's zero, almost zero, or like I said, within 20 to 10%. These are definitely candidates that need to be downsized, okay, from a memory and a CPU perspective. Now, what I'm using here is a 14-day hourly collection period. So there's 338 data points that we're measuring. We can also show this for I think I built 90 and 180 days as well. I can go back to 13 months to show that level of history. Now, the thing is, in the data warehouse in OCI, where we're collecting performance metrics for 14 days hourly, but then we collect daily metrics back for those 13 months. Okay, so it does make a difference what you select. I find the density of this CPU utilization and memory utilization over that 14-day hourly period seems to work best. But again, you folks as to what you want to do and how you want to use it. And we can provide that for you. So once we have an idea of where we stand, what we do is we model the data. We take a look at the current CPU sizes, the right sizing as is versus used and optimized, and then we take a look at the optimized virtual machine sizes after we run it through our algorithm. Okay, now the algorithm's clearly defined right here. It's basically what I use to optimize the environment. I'm not going to spend too much detail on that, but you can definitely take this and look at how we calculate the optimization. And this is highly customizable. All right, so we can change this, based on your needs and your business requirements. So keep that in the back of your mind. This is highly flexible. And then we look at the capacities, the virtual machine I/O densities. From a IOPS per terabyte perspective, we look at the as-is capacities versus the optimized capacities. I'm more interested in looking at this from a CPU and memory, because that's basically how the cloud, how the hyperscalers will charge you. They'll charge you, AWS focuses on CPU and memory. Azure will focus on CPU, memory, IO, and capacity from their rate card perspective. Okay, so I have all four of the hyperscalers that we support currently to show you how that is calculated. Okay. Now, once we have an idea of where we stand versus our as-is or current environment, and compare that to our optimized environment, we can look at the cost savings based on if we indeed intend to lift and shift, what is it going to cost me? All right. So this is for AWS, and I'll basically show you the other hyperscalers as well. All right, so for AWS, using on-demand pay-as-you-go rate cards, okay, and we can change those rate cards, based on either your on-prem cloud environment, or even if you have, existing off-prem, we can use those rate cards to calculate these values a lot more accurately, because most folks obviously do not use, pay-as-you-go, or what I call retail rate cards. They have discounts, right? We can pack the discount in there a number of different ways. We can add your rate cards. We can add your on-prem costs versus your off-prem costs. We could also add in a filter, a prompt, to allow you to actually, add a discount on the fly when you run this. In OCI's data warehouse. Okay, so you can actually put in a 10%, 20%, 30%, discount value if that makes it easier for you to calculate. But right now, this is just pretty much the latest and greatest. I just downloaded the latest rate cards from Amazon, and this is what it would cost. So I have, in my environment, it's small. It's 1,859 instances that are on-prem. For this month, there's 744 billable hours. The estimated monthly costs based on as is. Again, I'm not making any changes to my environment. So if I intend to lift and shift my entire existing on-prem environment over to the cloud, it would cost me $1.3 million per month as is. Okay. However, if I go through the process of optimizing, all right, whether it's something that needs to be downsized or upsized, and I can selectively choose those as well. It doesn't have to be the entire environment. But if I did the whole environment and I want it to lift and shift, but optimize first, optimize the environment based on the detail that this report provides, I would save up to 68% of the costs. Okay, and that's a recognized savings of almost $900,000 per month. And it's important because you really need to know before you put anything in the cloud, what is it going to cost you up front, right? And even though, like I said, these are retail rates, we have the flexibility to add in your discounts, add in your on-prem costs, and really give you a good number, a good feel as to what, it would take, to lift and shift and where you could recognize savings. Now, the last tab I have here is the machine details. So this is every single instance in the environment. Now, what I focus on with these numbers at the top are the lift and shift candidates that I have recognized that would, show me a savings based on downsizing their CPU and memory requirements. Okay. Now I know there's a lot of caveats there. I get it. There's some folks, once they allocate resources, they never go out there and change them, regardless of how they're performing. And that is totally understandable. However, you can go and look to see if there are candidates that are severely underutilized, and you can capture this data over several weeks. I mean, you take this report, and then take another snapshot, a couple of days later or a week later or whatever it may be, and compare, how static these values are and where, you can recognize savings based on those, severely underutilized instances. So what I do is, from the left to right, I look at the application that may be running on that specific instance. I have the instance name, of course, the operating system, the current as-is cores in memory, all right, and then any provision capacity. All right, so I have provision. I also included used, whether it's on-prem or off-prem. Okay, and then I look at the as-is configured. So I just throw, if it's greater than 32 or greater than or equal to 32, I just throw in a marker there. It's nothing, it's just for my own reference. And then I look at any, what would it cost me using an S3 bucket for that specific capacity. Okay, and these are also retail rates for S3. So I look at that cost, and then I look at the as-is monthly cost based on retail AWS rates. All right, so this is what it would cost me if I just threw this over the fence into the AWS environment. Didn't, just basically said, all right, I need, 8 cores, 32 gig of RAM, and I'm just going to throw it over there based on that. And, I'll just get it to whatever the default configuration type is. I'm going to choose that for that specific platform. It would basically cost you $357 per month for that instance, right? Now, if we go through the optimization, so I look at the max IOPS, the max throughput, the max of average CPU, the max of average memory. I look at the IOPS, the IO density. I look at the absolute used cores in the environment, the used memory. I look at after running through this data through my algorithm, I come up and say, all right, well, I don't really need 8 cores. I only need 3 cores, all right? And then I look at the optimized memory. I don't need 32 gig of RAM. I only need 3 gig of RAM based on my utilization. It's severely underutilized, right? So even if I rounded this up, which I actually do in the algorithm, I come up with a proposed configuration type based on that formula, that algorithm, that optimization formula that we placed in the code. All right, and then here it recommends a T2X large platform in AWS. Based on the billable hours, it would be a monthly cost of $171 a month versus a default of $357. Shows your absolute savings of $185 a month. Okay, so it gives you that recommendation. Now I realize that this is not an absolute ideal what do you call it? Way to just lift and shift. I get it, because there's different requirements out there. There's things in your environment that you just cannot move, you cannot change, you cannot modify. All right, and then you have change controls. I get it. There's a lot of IT specific tasks that need to go into this. However, even if you took 20 or 30 of these devices a month or a week, and then you optimize these based on these numbers, the consistency of these numbers, you're going to save resources, you're going to save money, you're going to perform better, okay? And you'll be more efficient from a even just focusing on-prem, okay? When you are ready to lift and shift to off-prem, this will help you identify what would be the best bucket? What is my proposed configuration type, and how does that platform fit in there, and what is it going to cost me? All right, so you can gauge, based on your needs, what would a specific platform or instance cost me if I bring it over based on the recommendations, okay, and the performance metrics that I'm using in OCI. Now we do the same thing for Azure. Now look at the costs here. And you can see right now, I'm realizing a cost savings of 68%. Now the same environment, I'm going to go and look at Azure. Azure costs are a little cheaper. All right, so the absolute same environment as is, would be 1.4 mil if I optimize. Okay, and again, the parameters, the algorithm is slightly different because of the way the rate cards are structured. So I'm going to get a cost savings of 77% by lifting and shifting to Azure. And again, I get that same level of detail. And then over here, I have my proposed configuration types for Azure. Okay, so you're able to determine what the best bucket is to lift and shift over for Azure. It shows you what your cost savings would be to do so. Right? Now, when we go to Google Cloud, all right, we look at Google Cloud, it's not quite as robust. The rate cards are not as robust as the AWS rate card and the Azure rate card. There's not that many selections. However, in Google Cloud, they do have a predefined calculator that I've embedded into the code, which helps a lot because, you know, if you have an optimized instance that doesn't fit neatly into that rate card bucket type, okay, we're able to calculate it outside of that. And you know, there's a lot of different scenarios that you can, you know, leverage from a services perspective with these hyperscalers. So we try to, you know, just give you a good idea of what it's going to cost and what the differences are between the hyperscalers, okay, based on those rate cards. And this rate card right here is current as of today. I actually just updated it today. All right, so that's the Google cost. Then I also have GovCloud. So if you're public sector and you have government-based customers, or you are your service provider and you're servicing government-based customers, this is definitely useful to go out there using the GovCloud rate cards and determine what the cost would be on a monthly basis versus the optimization process that we use with OCI and our algorithm. And again, under definitions, I've laid out the algorithm. It's basically the same algorithm to optimize. The only difference is the rate cards and how instances are distributed once you run it through that algorithm. So, when I calculate optimize CPU, this is the formula that I use, and the same for memory. I'm basically taking a look at the peak CPU, and then divide it by 60%. All right, and then that gives me a number of cores that I need. And that number, again, that's a consensus number value that I got from different customers that I've worked with over the last year and a half. And it pretty much everybody agreed that 60 and 70% for CPU and memory would be a good value. Again, very changeable, very easy to change. You're talking all of about 3 minutes to change this. And even if you wanted to update the rate cards very quickly, I mean, we can do it probably within 10 or 15 minutes to facilitate any changes that you have, or if you wanted to leverage your own rate cards. Okay. So like I said, this is free. We will modify it for free if you want to make changes, and we will provide this if you want all 4 instances, no problem. We'll provide all 4. And this version that you're looking at is out of the box. You just load it into Cognos and run it, and you will get this output in a tabular format. Now, I have not included off-prem in this version. I do have other versions that have off-prem for AWS and Azure, so that is available. And again, I also have versions that will go back 90, 180 days, and that value is changeable. So again, recommend best practices to stick with the 14 days hourly, because you get 338 data points, which is pretty dense, a pretty dense sample. But again, you tell me, all right? And if it's something you want to change, not a problem at all. All right, so that is cloud optimization. Like I said, very easy to deploy. I encourage you to take advantage of it, and please provide feedback to me. And as we evaluate that feedback, I will definitely look into making those changes for everybody and make it available. Any questions so far?
Looks like we have one in the chat window. Do you need a specific OCI version for this?
No, it doesn't matter which version of OCI. We can go from, we'll go back to 7.2.3 all the way up to 7.3.8. All right, so regardless of that, anything in between there, we can support you.